Hello, today I want to talk about Stellar and how to quick start writing a transaction. The Stellar documentation is already full of examples and explanations. Actually, a few days ago, the Stellar website has been completely revamped and it's loaded with examples. However, I think it may be interesting to start from scratch before talking about more advanced use cases. Moreover, looking at a video is probably easier for you than actually following, you know, um, a blog post or something. So for this example, we're going to use the JavaScript SDK. It's going to be quite code focused. And we're going to create two test accounts, one for Alice, one for Bob. We're going to fund those accounts, just adding actually tokens. And we're going to perform an exchange between those accounts. So as you see, it's pretty straightforward indeed. Okay, let's jump in. Okay, so first we are going to initialize the NPM runtime. Then we're going to install the Stellar SDK, obviously. Okay, should be quick. Okay, so now we got our base files. We're going to create a script folder, and in it, we're going to create a new file that will contain what allows us to just create the accounts. So an account is simply a pair of public and private keys in Stellar. It's very simple. And the SDK provides something to create that. Another thing is that we are going to record these two accounts in one file. So this is why we're going to import the file system dependency of Node.js. Okay, so the file name will be named like account.json, for example. And yeah, simply we're gonna be a bit lazy. Just use the write function, sync write function of Node.js to create this file. So obviously we want to write text in the file. We cannot write anything else or buffer. So we're going to stringify whatever we are going to write. So say we have Alice and Bob. We can map on these two items just to create the key pairs, public and private. Okay, so simply creating a constant with the actual pair key value for each of these accounts, Alice and Bob. So for that, Stellar provides the stellar.keyPair random method, which will simply create public and private keys. So the data structure is a bit more complex, but we're going to just extract from this object the secrets and the public key from it. So it's pair.secrets, and it's going to be pair.public key. So each time it's a method. Okay, there you go. And we're just gonna return that. So let's try this this file, see if it generates the accounts accordingly. Okay, we can see the JSON file here, and in it, yeah, Alice, the secrets, and the public key. Same thing for Bob. Okay, now what we want to do is create another file because we want to fund those accounts. We just created them. So let's call it one underscore. Let's just keep track of the order of the execution of those scripts. So we want to fund these accounts. So same thing, we're going to import the Stellar SDK. But we'll also need to install, for example, Axios, because we want to do an HTTP request against the friend boat. So the Stellar test network provides a some sort of faucet. It's going to give us, or give a specific account, some tokens. And we have to contact this friend bot via an HTTP request. So Axios is quite handy for that. Okay, we can require our accounts, so the JSON file that we just created, just to load the public keys actually. And yeah, let's say that we have a function that is fun accounts. So it's going to be all asynchronous because we've got some file system reads, and we're going to have also HTTP requests. So it's all asynchronous code. And we're going to wait for all the accounts to be funded. So hence the promise at all. Okay, so let's iterate on our accounts, Alice and Bob. And for each of them, we're going to get their data, public and private key. We only care about the public key for now. We don't need anything about private key so far. Okay, so and yeah, we're going to use Axios to contact the friend bot. So URL is quite simple. It's /slash friendbot, and the parameters. So that's the Axios we are writing this. The base URL will be on the Stellar test account. But oh yeah, so we use the Horizon testnet server, which is provided by the Stellar Foundation. And the parameter will be just simply, it's going to be the address itself. So in this case, it's going to be the account that's public key. Public keys and addresses are quite similar in Stellar, even though you can actually have some sort of aliases, but we'll see that probably later on. Okay, so let's go. Let's fund our accounts with our accounts. So maybe, yeah, want to make sure that, we have got a message if everything went fine. So let's say console.log okay. And if something goes bad, we just want to log the error in the console and simply throw the error so that the return code will be different from 0. Exit code. Okay, let's have a look. Let's try these scripts. Go. Okay, it worked. Seems it worked. So now we have to verify that actually we've got something on these accounts. A Stellar accounts, so a public key, only exists on the network if it has more than, I think, 0.5 Stellar elements. So now they should have more than 0. The friend bot should have given them about 10,000 Stellar. So we'll see that with this check balances script. So same thing, we don't need Axios anymore. We just want to import the Stellar SDK, just like for the first script. Okay, so let's create a new server. So this server will be the Horizon server we saw just before. With Stellar SDK, we have to kind of wrap those informations around with constructors. So we're gonna have like full fledged objects. There might be other use case for that. Anyway, the server object now has several methods that allows us to communicate in an easy way with it. And yeah, let's create this check accounts method or check balance. Anyway, same thing. It's going to be all asynchronous because we are going to first pull the accounts from the Horizon node, just to make sure that they do exist. Also, when you do that, you actually get what is called a sequence number, and for now we won't use it, but it's gonna be very important for the next steps, next videos, for more advanced use cases. So far, we don't need it for now. Okay, so for each of these accounts we have, we want to just map on it and simply load the account's contents. Let's go. So this is where the server has a nice method, which is the load account method. And we just provide the account ID or the public key of the accounts. So we're going to use this for all our accounts, Alice and Bob. And yeah, we're just going to return some sort of an object that gives us these the accounts. We maybe want to avoid having too many information about it. So that's what we can do now. We can say that we only want an object with the account ID or the public key. And the balances. So, well, you know what? Yeah, we can extract directly this from what is in the map object. So we can do that directly. Maybe it's easier. Yeah. Let's extract ID and balances. And we just return that. Okay, that will give us what we want. Okay, let's do that. Check accounts on our accounts. And same as before, if things are okay, we just say we print out the object we've just created. And yeah, if something failed, then we just want to throw the error. Well, log the error and throw the error, same as before. Okay, let's try this. Okay, so yeah, we can see our accounts. Seems they do exist, but the balances are full-fledged objects. So we're going to use the inspector, the util inspector method of provided by Node.js, the util library. It's going to be easier then. Don't remember, yeah, false null. Okay. Small mistake on false. Let's try again. Okay, now you've got it. So as you can see, the balances are 10,000 each. Also, you just saw that was written using strings, and that's coming from the fact that we are using big numbers under the hood. So yeah, we are not using the number primitive, but using a string primitive for this kind of numbers. Okay, now what we want to do is obviously to perform that transaction we've been talking about. So we created our accounts, funded those accounts, checked that the balances were fine now. So let's create this transaction we've been talking about. Okay, new script, make transaction. Same thing, we import the Stellar SDK, the Stellar library. We are using the same server, obviously, which is the testnet. We could use some sort of common configuration, but this is an example, so we just cut things in very, very small parts. Okay. One thing with Stellar is that you need some okay. So we're going to call this transaction, make transaction function transaction. Maybe we change that later on. Anyway, same thing. It's going to be an asynchronous function because we are going to use loads of asynchronous processes. And the first thing we want to kind of pull is the standard fee. So in previous versions of the Stellar SDK, you didn't have to provide this information, but now you do. So we're going to pull the fee value from Horizon itself. So as you can see, the server.fetch base fee would provide us this information. It should be 100 strup, which is an extremely low amount of kind of money if you convert that to, I don't know, British pounds or US dollar or euro. And then we are specifying our transaction options. So the fee is just the standard fee we just pulled. And this kind of network passphrase, which is another attribute, allows us to say, okay, by the way, I want to use the testnet. So it's just a way to say that in this example, we are using the testnet. Should you use that in Horizon, in production, on the mainnet, you would not add this network passphrase. Okay, so the payment to Bob now is another object we can create. We're just gonna say the destination. The destination is Bob's public key. So now we are gonna have to import our account's informations. Okay, let's say that for now we consider we've got this information as a parameter of this function. Let's say, yeah, Bob accounts, Bob key. Okay, so that's going to be our destination. And then we just want to precise what kind of assets we want to send. Stellar supports many different assets. We'll see that in another video. But now we just want to have the native asset of Stellar, which is the Stellar elements. And finally, we might want to precise the value, the amount of tokens we want to send from Alice to Bob. So same thing is going to be a string because of the nature of how JavaScript handles numbers. We may use only strings so far. If you need to do some computations, you may use, for example, the big number library, which is I think, used under the hood by the Stellar SDK. Okay, so the account of Alice is something else we're going to have to pull for now. These are very simple scripts, so they are self-sufficient, hence the fact that we may have to load those accounts several times, which is fine for testing. So let's same thing. We consider that we've got the public key of Alice as a parameter of this function. It's going to be easier to write. And yeah, under the hood, this gives us actually the sequence number of the account of Alice, which is very important to create any transaction in this network. And now, finally, let's create this famous transaction. So Stellar has a builder for transactions. It's the transaction builder constructor. And in parameter, we'll simply pass it the accounts that is being used to do this transaction. In this case, going to be Alice's accounts and the options of the transaction. So the fee and the fact that we are now using the testnet. So from that transaction builder, we're going to also add some operations. One operation in this case, which is the payment. So let's go for the payment. So we're going to just simply use the payment to Bob objects. And once this is done, well, we could add a memo, but let's not add a memo for now. We simply just finished with it. A memo is simply a small message you can add to a transaction or to any transaction. It can be needed for debugging, for example, or just simply so that people know what's going on with this specific transaction. Final thing is that you have to precise the timeout of your transaction. The timeout means that you can say to the network, I want my transaction to be valid for a given amount of time. Say that, for example, the network is stuck for 2 hours, just like what happened before. Maybe you don't want the transaction to execute after those 2 hours. You say my transaction has to be executed in the next 5 or 10 minutes or 1 hour, and that's it. In this case, we want to have an infinite timeout. We don't care when it's going to be executed. And we finished by the build method, which will definitely create the transaction object. So the next step is to actually sign this transaction. And for that, we're going to use the sign method, which comes with this newly created transaction object. And we want to pass the private key of Alice, because Alice is creating this transaction. So same thing, let's consider that we've got Alice's private key. Well, Alice secret. Okay, now the transaction is signed. It's still the same object, but slightly different. And the last step is to simply submit this signed transaction to the network. So as you can see, everything has been done, I would say, out of the network. We've been creating all these transactions and the operations in it on our computer. And the only thing we want to do then is to and even sign this transaction. We just then want to submit this transaction to the network via our node Horizon server. So that's what we're going to do. Same thing as before. We're going to run this function, providing the right parameters. So Alice and Bob that we extract from our accounts. Okay, so we just want to call our function transaction. Maybe it's not really well named. Let's call it, I don't know, like transaction or something. Yeah, run transaction. Okay, so we need Alice's public key. We need Alice's private key and Bob's public key. Okay, let's try that. Then, same as before, if things are okay, we just have a message that says okay. If not, we just catch the error and throw the error again. Okay, let's try that. Boom. Okay. So, okay. So it comes from the fact that the secret of Alice is not the right object. Same as before, Stellar consumes lots of its own objects. So having directly the string of Alice's secret is not enough. We have to create a fully fledged object from it. Okay, seems to have worked. Let's try to verify the balances now. And there you go. So Bob has now 1,100 Stellar, and Alice's has lost also its 100 stroops. So yeah, there you go. We've done that. It's been quite quick because so we are on the testnet, but I think the mainnet is as fast nearly. It's 5 seconds, and your transaction has been written in the ledger. So yeah, in a nutshell, now you can create an account, create those accounts, fund those accounts with the friend bots, and okay, the balances are the same. So these are brand new accounts we just created, and make the transaction again. Okay, 5 seconds, and should be fine. Let's check the balances. Same results, fine. It does work. So yeah, that's how you do it. So in a nutshell, we can see creating an account. It's about using this kind of keep a random file method. Funding accounts, you use the friend bots, and when you want to load an account, use the server. And to make a transaction, it's a bit more complicated, but to be honest, yeah, it's quite simple actually. You just have to precise these standard fees. So maybe you can hardcode them, but I would suggest that you fetch them. Also, you could actually use twice the number of fees because it's so cheap, and it's not impossible that your transaction might be, rejected if you just provide as little as 100 stroop. Okay, and yeah, then you have to sign locally your transaction. So all of this is done on the JavaScript runtime. But in the end, you could export a signed transaction as an XDR string, but we'll see that in another video. Okay, hope you enjoyed it, and see you next time.